All right. Good morning, everybody. Today we are going to be doing some practice problems on the law of conservation of energy. So I showed you the formula yesterday. Yes, it is very long, but it's easy to use. It's just going to be time consuming. So right now we're going to go over 3 practice problems, and then you're going to do your assignment for today. It's pretty easy. Fill in the blank, step by step. I don't think you'll have any problems. You might have problems on the graphing part, which is the very last question, but I'll be on Zoom the whole time. If you have any questions, you can just let me know. So let's go ahead and do our practice problems. I shared the paper I'm going to be doing with you. So yours should look like this. Zoom in on that. We're going to do the first 3 today, and then we'll do the next 3 tomorrow. So the law of conservation of energy formula, we have 2 sides. We're going to have a before side. That's the initial. And then we're going to have an after side. That's the final. So before and after. Was that the bell?
Yep.
Am I early? That's weird.
No, it's 9:06.
Okay, so for the before, you're going to have your kinetic energy, initial, plus your gravitational potential energy, initial, and all of that is going to equal to your kinetic energy final plus your gravitational potential energy final. And then, of course, within each of these formulas, we have their formulas. So technically speaking, kinetic energy is going to be 1/2 of the mass times the velocity squared. Remember, only the velocity is squared, nothing else. And you're going to add that to your mass times your gravity times your height. And again, all of this is before the initial part. It's the first numbers that you're given. And then that's going to be equal to your final kinetic energy, which is 1/2 mv squared, plus your final gravitational energy, which again is mass times gravity times height. So this is the formula we're going to be using today. I promise you, it might look confusing, but it's pretty easy. It's just going to be very long. Very, very long. And of course, I'm going to be doing everything step by step. So if you're taking notes on this, you don't have to write everything I'm writing. Just write the stuff that you think you're going to forget. Trying to zoom in as much as I can. Okay. So with the first problem, in the bottom of the 9th inning, a player hits a 0.15 kilogram baseball, so kilograms measures mass, over the outfield fence. The ball leaves the bat with a speed of 36 meters per second. So that's my velocity. And a fan in the bleachers catches it 7.2 meters above the point where it was hit. 7.2 meters, that's my height. Assuming that the frictional force can be ignored, find the speed of the ball just before it is caught. So we're looking for the speed just before it's caught. That's our velocity. All right, so we went through and we underlined everything we know and everything we need to know, but we need to figure out exactly what we know, because remember, you have a before and you have an after. So you need to figure out, is this velocity you're before or after? Is this velocity you're before or after? So you're gonna need to read the words and you're gonna have to play it out in your head to figure out which is which. It says the ball leaves the bat with a speed of 36. And then we want to find the speed just before it's caught. So do we want to find the initial speed or the final speed? We want to find it just before it's caught. So we want to find the final. In this scenario, a bat hits a ball, the ball goes flying into the stands, somebody catches it. So we're talking from the point the bat hits it to the point someone catches it. If we want to know the speed just before it's caught, we want to know the final, which means this one has to be our initial. And then the height, is this going to be our final height or is this going to be our initial height? It says a fan in the bleachers catches it 7.2 meters above the point where it was hit. So it was hit and then it went 7.2 meters above that. So is this our final height or our initial height? Final. That's going to be our final height. So that's our F, final height. And that's honestly the hardest part, figuring out which numbers are which. So now we're going to plug in our formula. Again, it's kinetic energy plus gravitational equals kinetic plus gravitational. But I'm going to write the bottom one because that's where I'm going to plug in all my numbers. So 1/2 mv squared plus my mass times my gravity times my height equals again 1/2 mv squared plus my mass times my gravity times my height. And now I'm just going to plug in my numbers. So 1/2 is the same thing as saying 0.5. I like using 0.5 in my calculator. My mass is going to be 0.15. And notice that mass doesn't change at all. It's going to be the same throughout the formula because we're talking about one object before and after. So the mass is going to be 0.15. We know our initial velocity is 36. And remember to square that number, only that number. Nothing else gets squared. Plus our mass again, which is 0.15, times gravity, which is 9.8, times our height. What was our initial height? Take a guess at what our initial height's going to be.
0.
0. Good job. Let's write that down so we don't forget. Initial height is 0. There's no initial height. Usually if I don't give it to you, it's because it doesn't exist. It's not there. So this is going to be multiplied by 0. And what's anything times 0?
0.
0. So we don't even need this part. And then again, now we're going to do the after part. So we have our 1/2 again, which I like using 0.5. Our mass again stays the same, 0.15. Our velocity after is what we're trying to find. So that's our v squared. That's our unknown. This is what we're trying to find. Plus our mass. Again, that's still 0.15. Gravity, 9.8. And our final height was 7.2. All right, so it looks like a lot, but it's easy. It's just multiplying. Maybe we have to do a square root at the end, but that's not going to be too hard. So first, make sure you multiply the objects that are together before you add. Remember PEMDAS, multiplication and division comes first. Well, exponents come first, then multiplication and division. But we can just do it all in once in our calculator. So I'm going to type in my calculator 0.5 times 0.15 times 36 squared equals 97.2. And then that's added to 0 because all of that canceled out to 0. And that's going to equal, I'm going to do 0.5 times 0.15. That's going to give me 0.075, but I still have my v squared right there. So I'm going to leave v squared alone. That's what I'm solving for. And then I'm going to add whatever 0.15. I'm going to type all this in, times 9.8 times 7.2. And that's going to give me 10.584. And now I'm going to keep doing my algebra. I need to isolate my variable. I need to get v squared alone, but first I need to get rid of this 10. Since 10 is being added, I'm going to subtract. I'm going to do the opposite. And what I do to one side, you have to do to the other side. Those are the rules of algebra. That cancels out over here. So I have 97.2 minus 10.584. That's going to give me 86.616. I still have my 0.075. And I still have my v squared. Now again, using the rules of algebra, I need to get rid of the 0.075 to isolate my variable. Since it's being multiplied, you're going to do the opposite. You're going to divide 0.075, and what you do to one side, you have to do to the other. That cancels out over here, so I'm left with 86.616 divided by 0.075.
There's too many numbers.
I know, I'm sorry. 1154.88. Well, I'm showing all my work. If you can do it without showing your work, you don't have to write all these numbers. All right, we're almost done. What is the last thing we need to do when solving for velocity? Square root it. Square root it, not square it. Do the opposite. All right, so square root 1154.88. Your velocity is going to be equal to 33.98 meters per second.
Are they only going to be asking us for velocity?
No, sometimes I'll be asking for height, which is actually the next practice problem.
Okay, cool.
And then honestly, sometimes we won't even have a final height. We'll just, it all depends. Sometimes it's easier. I'm showing you worst case scenario. All right, any questions on that first one we just did? A lot of work, but I'm proud of you guys. No one logged out yet. All right, let's go on. So in number 2, in a tennis match, a player wins a point by hitting a 0.059 kilogram ball. Again, that's our mass. Sharply to the ground on the opponent's side of the net. If the ball bounces upward from the ground with a speed of 16 meters per second and is caught by a fan in the stands when it has a speed of 12 meters per second, that's another velocity. How high above the court is the fan? So we're looking for how high it is, so that's our height. Now we need to figure out what exactly we know. So the ball bounces upward from the ground with a speed of 16. Is that going to be our initial velocity or our final velocity? 16. That's going to be our initial. So it goes from the ground with the speed of 16 and it's caught by a fan in the stands when it has a speed of 12. So that's going to be our final. It goes from 16 to 12. Now we want to know how high above the court it is. Is that going to be our final height or an initial height? That one's going to be our final because it bounces from the ground. So if it's from the ground, what's the initial height going to be? 0. So initial height, again, is going to be 0. So do we even need our initial gravitational potential energy? No, we don't need that. I'm still going to write it, but you don't need it. All right, so our formula, long formula again, 1/2 mv squared plus mass times gravity times height equals 1/2 mass v squared plus mass times gravity times height. But like I said, this initial is 0, so we do not need to plug in this part. So now plugging everything in. 1/2, I'm going to use 0.5 again. Mass is going to be 0.059. My initial velocity was 16, and I'm going to square that. This is going to be 0 because anything times 0 is 0, and that's why we don't even need that. And then again, 1/2 is the same as 0.5. My mass doesn't change, it's 0.059. My second velocity was 12. Don't forget to square that velocity. That velocity always needs to be squared. My mass, again, is still 0.059. Gravity is always 9.8. And we are looking for that final height. This is what we're looking for. So this one's going to be easy because in the end, we don't need to square root anything, but it's still going to be time consuming. It's still long. We're going to do the same thing we did last time. We're going to multiply everything that needs to be multiplied first. We don't add until we're done multiplying. So in my calculator, I'm going to type 0.5 times 0.059 times 16 squared. That's going to give me 7.552. That's going to be equal to 0.5 times 0.059 times 12 squared. Don't forget to square your velocity. 4.248. Then I'm going to do my height. My mass times my gravity. 0.059 times 9.8. That's going to be 0.5782. And I still have my height because that's what I'm looking for. Again, rules of algebra, you need to get rid of this number. Since it's being added, you're going to subtract 4.248 from both sides. That cancels on your right, so 7.552 minus 4.248. That's going to give you 3.304. And that's equal to, we still have 0.5782 H. And the very last step, all you need to do is divide. Just divide by that 0.5782 number. You're left with your final answer, 3.304 divided by 0.5782. Your height is 5.71 meters. Like I said, it's easy, it's just really long. All right, so I want to make sure you understand this. You're going to do the last one by yourself. I'm going to show you the answer in a minute, but I want you to try it without my help. Any questions on number 2 before we do the last problem? All right. Last problem. I'll give you a minute head start. Just so I can make sure we're all on the same page, does anybody want to tell me what they got for initial velocity?
0.
Good job, 0, because we're about to drop it. We haven't dropped it yet. Anytime you're holding something and about to drop it, initial velocity is 0. Good job. Gage, I know you're not watching a video and you're doing your math problem.
Sorry, it helps me relieve stress.
You're gonna have more stress if you don't know how to do this, though.
Yeah. Yeah, I see that. I've actually been writing them down.
But writing down isn't the same as understanding. You know what you're doing.
Yeah. I'll pay attention to this one.
Okay.
I'm gonna ask all my teachers if they had trouble with Zoom period. Hopefully one of them says yes, so it's not just my end. But then again, I might have a theory why I did that. Because I wasn't in Zoom or anything, but on my lunch break, the Wi-Fi and everything connected to it completely shut down at my house.
Hmm.
But when it restarted, everything was fine. So it's probably not that. And every time I tried to sign into Zoom, I click to sign in, it would say an error has occurred. It doesn't say like I did the wrong password. It says an error has occurred.
You might have to call.
I mean, it happened before, but then it immediately fixed itself.
Hmm.
And just talking to you now is making me lose focus.
Sorry. Well, you're supposed to try this one by yourself first. Let's stop coughing. Just write it yourself and then look up to make sure you're doing it right. I don't know why I put a parentheses there. All right. Hopefully when you're done, you can look up and see that you got the right answer. If you need any help or you don't understand something, let me know. If you are already done and you got the right answer, good job. You could go ahead and start your work for the day. Again, I'm going to stay on Zoom the whole time if you need help. If not, you are free to go.